Good evening, ma'am.
Hello, good evening. Okay, Hamna and Mridula are here. Let's wait for 2-3 minutes for Miraj. I'll start the class then. Hello, Hamna and Mridula.
Hello, ma'am.
Hello. So, are you maintaining your notebooks, both of you?
Yes, ma'am.
Okay, Hamna, please unmute your mic.
Yes, ma'am.
Okay. So, are you facing any issue?
No, ma'am.
Okay.
No.
So, have you understood so far what I have taught you in this chapter? Are you able to solve all the questions?
Yes, ma'am.
All right. Miraj is still not here. All right, let us start. So both of you please unmute your mic so that we can talk to each other because I want to ask you some questions. All right, so in the last class, we already did the exercise number 6.1. Any problem to anybody in that exercise?
No, ma'am.
No.
No, ma'am.
Okay, let's move forward. So now in this next exercise, we have to study when we have two parallel lines and then there's a transversal cutting those parallel lines. So you already know what is a transversal, right?
Yes, ma'am.
Okay. All right. So now tell me, I'm going to ask you questions. Now, if you have two parallel lines, okay, this is any transversal cutting these two parallel lines. Now I'm naming angle 1, 2, 3, and 4. Then 5, 6, 7, and 8. All right. Now, Hamna, tell me the pair of corresponding angles. It's a quick revision. I already taught you this in the last classes. Which angles are corresponding to each other here? Tell me.
Ma'am, the first and second.
First and second, no, they form a linear pair, Hamna. They are not corresponding.
Ma'am, first and fifth.
5, yes. Angle 1 and angle 5. Say it like this, okay?
Yes, ma'am.
And angle 5, okay. And
4
the
and
next
angle
pair,
8.
and
Angle 4 and angle 8.
angle 4 and angle 8. Okay, fine. Now Miraj is here. Hello, Miraj. Hello, Miraj. Can you hear me?
Yes, ma'am.
Yeah, Miraj, please try to join at time because we always wait for you, right?
Yes, ma'am.
Okay, so it's I have just started. So far, any problem to you, Miraj? Any question you have not understood?
No, ma'am.
Okay, let's move forward. So in this exercise, now what do you have now? You have two parallel lines. Okay, now A, B, C, D are parallel lines, and then there is a transversal, let's say PQ, which is passing through these parallel lines. Now these are the angles I have named, and I asked Hamna that which pair are corresponding angles. So she said angle 1 and angle 5, angle 4, angle 8. Now Miraj, you will tell me alternate interior angles. Tell me.
3, 5, and 2, 8.
Very good. 3, 5, and 2, 8. All right. Now Mridula, tell me alternate exterior angles.
Ma'am, 6 and 4.
Okay, and
Ma'am, 7 and 1.
7 and 1. Okay, that's good. Miraj, tell me interior angles on the same side of transversal.
2 and 5, 3 and 8.
2 and 5, 3 and 8. Okay, so you people remember this much. That's fine. Let's move forward. Now try to understand one thing which is very important. Okay, let me start with the axiom now. Wait, what I have next? Okay. Now, see, I already taught you what is linear pair axiom in the last class. Please, this is very important. Pay attention to this. So we did linear pair axiom because I'm repeating it because it is important. And if you will remember this, you will be able to remember the other axioms also properly. Okay. So there are two statements. One is the linear pair axiom. Another is the converse of linear pair axiom, right? Converse mean opposite. So what is linear pair? That if it is given to you, you have a straight line. Okay. What is given to you? That AB is a line. Please remember, if it is given that AB is a line, okay, and then you have any ray on this. Now you have this angle 1 and angle 2. So if it is given that AB is a line, so this implies angle 1 is equal to angle 2. Fine?
Yes, ma'am.
Yes?
ma'am.
Sorry, I'm so sorry. Not angle 1 is equal to angle 2. Angle 1 plus angle 2 is equal to 180 degree. I'm really sorry. So this is linear pair axiom. Now what is the converse of it? Hamna, tell me. What is the reverse? Okay, anybody tell me who remember it? Okay, if I'm writing converse, so what is given to you here? Mridula, tell me.
Angle 1 plus angle 2 is equal to 180 degree.
180 degree. Okay, now reverse is given to you. So angle 1 plus angle 2 is 180. It's already given to you. So Miraj, what will it imply that?
1 is equal to
No, see, you have to tell me the exactly opposite of this thing. Now, in this case, it was given that AB is a line. So it implies this, okay? Now it is given that 1 is equal to 180, it's already given. So what does it imply?
angle 2 is equal to 180 minus 4, I guess.
That is obvious. This is mathematical calculation. This is not an axiom. Okay, 180 minus, that is fine. It implies that AB is a line, right?
Yes.
Look here, if it is given that AB is a line, then angle 1 plus angle 2 is 180 degree. If it is given to you that it is already 180 degree, but it is not given that AB is a line. So if this information is given, that means AB is a line. All right.
Yes, ma'am.
Please remember what is the axiom and what is the converse of that axiom, because you need both of them to solve questions, to prove questions. Okay.
Yes, ma'am.
Now let's move forward. Now, similar to the linear pair axiom, you have corresponding angle axiom now. Okay. I'm giving it name. Please note it down in your copy also. This is very important. You will need it in your exercise. Sorry. Corresponding angles axiom. Okay. Now look here, all of you, please carefully, very carefully write it afterwards. I'll give you time. So in the linear pair axiom, you had only one line. Okay. Now corresponding angle axiom, you need two parallel lines. So if you have two lines, okay, let's say you have line AB, then you have line CD. So I'm not drawing arrows because that takes a lot of time. Now there's a transversal which is intersecting this these two parallel lines. All right. Now you have angle 1, you have angle 2, and then you have angle 3, and then you have angle 4, and all the other angles also. Okay. Now one thing is given to you. So it is given to you. See, if a transversal intersects two parallel lines, so it is given to you that AB is parallel to CD. All right.
Yes.
If it is given that lines are parallel, this implies that corresponding angles are equal. Okay.
Yes.
Angles are equal. All right, Hamna?
Yes, ma'am.
Yes. Mridula, fine?
Yes, ma'am.
So this is similar to the linear pair axiom. So there it was given that AB is a line and therefore you had the sum 180 degree. Now similarly here it is given to you that AB is parallel to CD and therefore corresponding angles are equal. Now Miraj, can you tell me the converse of this axiom? Okay, now converse will be if it is given to you that corresponding angles are equal. Okay. So opposite is given to you. It is given to you that corresponding angles are equal. Now this is given. So what does it imply, Hamna?
Ma'am, that AB is parallel to CD.
Exactly. It implies that lines are parallel. All right, Miraj?
Yes, ma'am.
See, this is how we write the converse. If one information is given, it implies the other one. If opposite is given, it implies the other one. So in some questions, it might be given that lines are parallel. So you can say, okay, because lines are parallel, so corresponding angles are equal. Now in some question, it can be given that angles are equal. From there, you can conclude that lines are parallel. Okay. So that's how you use it. So this is called corresponding angle theorem and it's converse. Please remember it. This is very important. So far you have learned two things. One is the linear pair axiom. Other is the corresponding angle axiom. So will you be able to remember this?
Yes, ma'am.
Yes, ma'am.
Okay. It's simple. Nothing very complicated. Please remember it. Okay, so this is exactly the converse I have written. If a transversal intersect two lines, see, it's not written two parallel lines. Look carefully, just two lines, okay? Such that a pair of corresponding angles is equal. So you only require one pair. I mean, one pair is enough to prove that lines are parallel. You do not require knowledge about all the pair of corresponding angles. Only one pair is enough, okay? So it is given to you that two lines are a transversal is intersecting two lines and one pair of corresponding angle is equal. So that implies that two lines are parallel to each other. So this implies that two lines are parallel to each other. So this is the converse of corresponding angle axiom. This is given in your book also. This is the picture from your book itself. So shall I move forward? Yeah. Shall I move or you want to write
Yes,
it
ma'am.
down? Okay, I'm proceeding forward. Uh,
I will write it.
sorry, who is speaking?
I will write it later.
Yeah, you can write it later. It is given in your book. Important thing is you please try to understand it right now. Okay, so we did linear pair, we did corresponding angle. Now come alternate interior angle. So there is also one theorem about alternate interior angles. All right.
Yes, ma'am.
Miraj, what is the difference between axiom and theorem? Tell me. In the last two classes, I told you what is an axiom. Anybody who remembers? Hamna, what is an axiom?
Ma'am, an axiom is the universal
Truth.
truth of the whole universe.
Hmm.
And theorem, we have to prove the theorem.
Exactly. Miraj, so will you be able to remember? See, axioms are truth. They are universally true. So if it is given to you that two lines are parallel, now if you take your protector and you measure the angles, like you measure the corresponding angles, they will come out to be equal. So this is the truth. Okay, this is universal truth. You don't require to prove it, but theorems require a proof. You have to prove it. That
The
is the
things which
difference.
are given.
All right. So it's a theorem that if a transversal intersect two parallel lines. So first let us draw two parallel lines to better understand it. These are any two parallel lines. Let's name them AB and CD. Okay. Now any transversal is there who is, sorry, please avoid my bad drawing. Wait. Okay. Now here is a transversal. again. Okay, anyway, you can draw, I think, better than me. I'm naming some angles, let's say 1, 2, 3, any name I can give, 4, 5. All right.
Yes, ma'am.
Okay.
Okay, so let's prove this theorem. So it is saying that if a transversal intersect two parallel lines, then each pair of alternate interior angles are equal. Please recall the corresponding angle. It is also the same. It also says that a transversal intersect two parallel lines, then corresponding angles are equal. Another now new thing is alternate angles are also equal, alternate interior angles. But we will prove it. So what we have to prove here? Which are the alternate interior angles? Tell me, Hamna.
Ma'am, 1 and 2. Angle 1 and 2.
Okay, 1 and 2. Okay, let's name it something, angle 6, fine. Okay, so 1 is equal to 2. This you have to prove. And the other one?
Ma'am, angle 3 is equal to angle 6.
Okay. Angle 3 is equal to angle 6. So this you have to prove. Okay, let's prove it. Okay, how can we do it?
Ma'am, we can use the converse of the corresponding angle axiom.
Okay, very good. Converse of the corresponding angles axiom. Okay, that's right. So how can you use it? Tell me. Okay, now look here. Angle 4 is equal to angle 2. Fine.
Yes, ma'am.
Amna, see, you don't require the converse here because it is already given that the lines are parallel. Fine. So you need corresponding angle theorem because the lines are parallel. So therefore angle 2 is equal to angle 4. Right? This is corresponding angle. They are corresponding angles. Is that okay?
Yes, ma'am.
Okay, it is already given that lines are parallel. So therefore angle 4 is equal to angle 2, corresponding angles, right?
Yes, ma'am.
All right. Now angle 4 is equal to angle 2 that we have proved. Now we have to prove that. All right, but angle 1 is equal to angle 2 that we have to prove. Wait. Angle 4 is equal to angle 1, isn't it? Yes, why? Miraj, tell me why angle 4 is equal to angle 1. Miraj, please speak up. They are vertically opposite angle, isn't it?
Yes.
Yes, Hamna Mridula, where are you? Please keep speaking.
Yes, ma'am.
Yes, ma'am. Okay. Okay. So now angle 4 is equal to angle 2. Angle 4 is also equal to angle 1. Therefore, angle 1 is equal to angle 2. Can we say that? Because LHS are same. You can write here LHS is same. So this implies that angle 1 is equal to angle 2. So we have proved that one pair of alternate interior angle is equal, which we were supposed to prove here, right?
Yes.
Yes, ma'am.
So similarly, can you prove that angle 3 is equal to angle 6?
Yes, ma'am.
Okay, so first what will you write? Similarly, what will you do?
Ma'am, angle 5 is equal to angle 6.
Very good. Why?
Ma'am, because of corresponding angle.
Corresponding angle. Very good. They are corresponding angles. And okay, angle 5 is also equal to angle 3. Same, vertically opposite, right? Isn't it? So again, LHS is same. So this implies that angle 3 is equal to angle 6. So another pair you have proved that alternate interior angles are equal. I think it's simple. Yes, Miraj?
Nothing.
Okay, write it down quickly. Theorems can also be asked in your examination. Tell me one thing, are you guys available tomorrow at 8:30? I want to take some extra classes.
Yes, ma'am.
Okay.
Okay.
Yeah, but I will confirm it by tomorrow. I'll inform you. So I might take a class because your exams are approaching. I want to finish this chapter in this week itself.
Okay. Sure.
Okay. All right. I'm moving to the next theorem. Shall I?
No, ma'am.
Okay.
Tomorrow we have science class at 8:30.
Tomorrow 8:30. At what time you can be available? All of three of you?
I'm at
6:30 India time.
ma'am. Sorry, ma'am. I'm not available in 6:30.
A bit later than 8:30. I mean 9:30 India time. Will you be available?
Yes, ma'am. At the time I'm available.
Yeah, Miraj.
No, ma'am, I won't be free at that time.
Okay. But your exams are coming. I want to take some classes.
I'm at morning 11, 12 a.m.
Yeah, will all of you be free? Just tell me that thing. I can take.
Ma'am, tomorrow is the holiday and ma'am, I'm free at that time.
Yeah, Miraj, are you free in the morning? Please say quickly.
No, ma'am, at that time I will be having offline
Ma'am,
classes.
Oh, okay.
Yeah.
All right, we will talk about it on the message, then leave it. Just write it down. I'm moving forward.
done, ma'am.
Okay. Okay, I'm coming to the next theorem now. Oh, I have not left the space here. Anyway. Now look here, this is the converse of the theorem we have just done. So if a transversal intersect two lines, now look carefully, it is saying two lines, not two parallel lines, fine? Then such that a pair of alternate interior angles is equal, then the two lines are parallel. So this is the exactly converse of that, isn't it, Miraj?
Yes, ma'am.
Okay, so, okay, let's try to prove it. Theorem, I'm doing it here. 6.3 statement. You can write it down later. Just look at the proof. It's easy. Let's have two lines, but we don't know whether they are parallel or not. They are line A, B, and C, D. Okay. There's any transversal cutting. Just draw all the angles. Similarly, I'm drawing exactly. Give the same number so that we can prove it quickly. Okay, let's call it angle 3. Okay, this is your angle 2. This, okay, let's call it angle 5. This is your angle 4. So what we have to if a transversal intersect two lines such that a pair of alternate interior angle is equal. So it is given to you that alternate interior angles are equal. That means angle 1 is equal to angle 2, which is given. Angle 3 is equal to angle 4. These are given. Fine.
Yes,
And what
ma'am.
you have to prove? You have to prove that lines are parallel. So AB is parallel to CD. This you have to prove. Okay, let's do the proof of this. Okay, now angle 1 is equal to angle 5. Why? Hamna, tell me.
Ma'am, vertically opposite angle.
Okay. And angle 1 is also equal to, yeah, it's given that angle 1 is also equal to angle 2, right? This is given. This is vertically opposite, right?
Yes, ma'am.
Now, since LHS is same, so this implies that angle 2 is equal to angle 5, right?
Yes,
Yes.
ma'am.
Okay. Now look at this is your angle 2 and this is your angle 5. So which converse we can use here? Miraj, tell me.
Ma'am, 1 second.
Which type of angles they are? They are alternate or corresponding? Angle 2 and angle 5.
Corresponding.
Corresponding. That means you can use the converse of corresponding axiom. It is given to you that angle
Yes.
2, yeah, we have proved that angle 2 is equal to angle 5. So by converse of, write it like this. So by converse of corresponding angle axiom, corresponding angle theorem, you can say line AB is parallel to line CD. So you have to write this line that by converse of corresponding angle theorem, AB is parallel to CD. You can even skip this because it says, okay, one pair we need. We don't require this information. See, it's saying a pair of alternate angles. So we have taken only one pair. That angle 1 is equal to angle 2. That's it. All right.
Yes, ma'am.
Okay. Done, all of you?
Yes, ma'am. Done.
Okay. Let's move to the, so far what we have done, linear pair axiom, corresponding angle axiom. Now we have started the alternate angle theorem. All right. So we have proved that alternate angles are equal, and if it is given to you that if it is given to you that lines are parallel, then alternate angles are equal. Okay. And if it is given to you that alternate angles are equal, then lines are parallel. Same in all the three. Fine.
Yes.
Yes.
Okay. Let's move to the next theorem, which is a bit different. Now it says that, look at this theorem 6.4. Okay, I've pasted all three on one page itself. If a transversal intersect two parallel lines, so it is given to you that lines are parallel, all right? Then each pair of interior angles, okay, next thing, interior angles we have come now, on the same side of transversal, are supplementary. Look carefully. So this time they are not equal, but they are supplementary. That means their sum is 180 degree. Okay.
Okay.
Yeah, please highlight the important things. First of all, parallel lines. Okay, it is already given that lines are parallel. Then each pair of interior angles on the same side is supplementary. So now we will prove it. Write down the statement quickly.
I'm done.
Okay, let's do the proof. Please write down the theorem number. So let's draw two parallel lines first of all, because it is given that lines are parallel. Okay. So there are two lines A, B, C, and D. Now it is already given that AB is parallel to CD. Lines are parallel. Now we have a transversal cutting these lines. Any transversal PQ. So what we have to prove? So we have to prove that let's say this is your angle 1 and this is your angle 2. So they are interior angles on the same side of transversal, right? So we have to prove that angle 1 plus angle 2 is supplementary. That means 180 degree. And if this is your angle 3 and this is your angle 4. So also we have to prove that angle 3 plus angle 4 is equal to 180 degree. So interior angles on the same side of transversal are supplementary. We are going to prove it. Let's do the proof. Okay, now see, first of all, if line, it is given to you that AB is parallel to CD, right? Given. So if it is given that lines are parallel, that means alternate angles are equal. We have just proved. Please speak up.
Yes, ma'am.
Yes, we have just done the alternate angle theorem, that if lines are parallel, alternate angles are equal. That means angle 3 is equal to angle 2, right? Alternate angles. I'm writing in short, you can write it completely in case you don't remember. Now, see, CD is a line, right? It is already given that there are two parallel lines. I mean, it is given that CD is a line. So therefore, angle 4 plus angle 2 is equal to 180 degree. Which theorem I have used here? Mridula?
Parallel theorem.
Oh, no. See, CD is a line. Angle 2 plus angle 4 is 180 degree. What kind of
Linear.
pair there? Linear pair, simple. Okay.
Yes, ma'am.
Now angle 2 is equal to angle 3. So can we write angle 3 here? Angle 4 plus angle 3 is equal to 180 degree. Can we write it?
Yes,
Like,
ma'am.
okay. This is 2. If you don't remember, write it like this. Use 1 in 2. So angle 4. So one pair we have proved that angle 4 plus angle 3 is equal to 180 degrees. So the interior angles on the same side of transversal is supplementary. We have proved that. Similarly, we can do for the other pair also. Now look carefully. Angle 1 is equal to angle 4. Why? Hamna, why angle 1 is equal to angle 4?
From alternate angles.
Alternate angles. Alternate angles. Now again, okay, we have to prove angle 1 plus angle 2. Okay. Now see again, angle 4 plus angle 2 is equal to 180 degree. Linear pair, same thing. So this time, in place of angle 4, write angle 1. Use this here. So therefore, angle 1 plus angle 2 is equal to 180 degree. So the second pair we have also proved that the interior angles on the same side of transversal are supplementary. Okay, shall we move forward? Written, all of you? Miraj, written?
Yes, ma'am.
Hamna, please speak up. Why don't you people speak up?
Yes, ma'am.
I'm done.
Miraj,
Yes, ma'am, done.
okay. So Miraj, will you please revise whatever we have done so far? Which theorems we have done? Tell me the names of the theorem we have done. First is the linear pair theorem.
Yes.
Then second,
If lines are parallel, alternate angles are equal.
okay. One is the alternate angle theorem. Okay. And the other one is, okay, there is
Altern
corresponding angle theorem. Please remember. See,
yes.
okay, there are theorems, and please listen carefully. There are theorems and there are converse of those theorems. So please tell me the name of theorem only. I'm not asking about the converse. So first is the linear pair theorem we have done. Then we have done the corresponding angle theorem, right? Then we
Yes.
did the alternate angle theorem. And the fourth one, which we are doing right now, is the interior angles on the same side of transversal. So these four, please remember, but in this case, they are supplementary. They are not equal, but supplementary. Now we have proved that the interior angles on the same side of transversal are supplementary. Now we will see the converse of this theorem also. So every theorem has its converse also. Okay. I don't have space. I'm writing here the converse I'm proving here. Okay, this is the converse of the same theorem. In your book, I think this is the fourth. I don't remember the name, but can you write the statement from your book? Or should I write? Wait, I'm telling you the statement. Okay, this one, 6.5 I'm using. All right.
Okay, ma'am.
Please read. If a transversal intersect two lines, see two lines, not two parallel lines, two lines such that a pair of interior angle on the same side of transversal is supplementary. So now this time it is given that the pair is supplementary. This implies that the two lines are parallel, exactly converse of the above theorem. All right, so theorem 6.5. Let's prove it very quickly. Then we are done with the theorems now. 6.5 of your book. Let me draw a figure to understand this theorem. Let these are two lines, but we don't know if they are parallel. This time we have to prove that the lines are parallel. Okay, now this is a transversal which is cutting these lines. Let's name angles. First of all, 1, 2, 3, 4. Here, 5, 6, 7, 8. Now draw the figure quickly.
Drawn.
Okay. So this time it is given to you that the interior angles are supplementary. So it is already given to you that angle 1 plus angle 5 is equal to 180 degree. Okay. Now you have to prove that, and it is also given that angle 4 plus angle 6 is equal to 180 degree. So this time it is given. Now you have to prove that the lines are parallel. AB is parallel to CD. Let's do the proof. It's very simple. First of all, it is given that angle 1 plus angle 5 is equal to 180 degree. Okay, given. This thing is given. Now also see here, this angle 5 plus angle 8, they are on the same line. So angle 5 plus angle 8 is equal to 180 degree. Why? Miraj, tell me why?
Linear pair.
Linear pair, exactly, very good. Now RHS is same. Though both 180, 180, so we can write angle 1 plus angle 5 is equal to angle 5 plus angle 8. So we have equated the LHS. Okay. Now
Yes.
angle 5 on both sides will get cancelled out. So you are left with angle 1 is equal to angle 8. Now look carefully. So you have got this angle equal to this angle. Now which theorem can you use here, Hamna? Which type of angles are they? Angle 1 and angle 8.
Ma'am, corresponding.
Corresponding angles. So corresponding angles are equal. Therefore, use the converse of corresponding angle theorem. When corresponding angles are equal, that implies the lines are parallel, isn't it? By converse of corresponding angle theorem, AB is parallel to CD. Okay.
Hmm.
Yes. Have you written? Shall I proceed?
Okay.
Okay.
Yes,
Now,
ma'am.
all right. So Mridula, will you please summarize which theorems we have done so far? Yes, Mridula. First one. Which one we did?
Ma'am, if ma'am
Tell me the names.
alternative
No, first of
in
all,
the
first tell me the names. First one is the linear pair theorem. Okay. Second one?
yes, ma'am. Ma'am, alternative interior angle theorem.
No, 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 no. Alternative interior is nothing. Alternate angle theorem. Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
Alternate interior angle. Fine. Then third one.
Ma'am, if the pair of alternate interior angle is equal, ma'am, then the two lines will are parallel.
Let me summarize it quickly for you. Please, this is important. Please try to remember all these theorems. Let me write it here. So first is the linear pair theorem. All right. Second, corresponding angle theorem. All right. Then we proved the alternate angle theorem. And then interior angles on same side of transversal, right?
Yes, ma'am.
Are supplementary. I mean, this time they are not equal, but they are supplementary. Okay. So linear pair says that if you have a line, then see, if you have a line and you have two angles x and y, so if it is given that it is a line, that means x plus y is equal to 180 degree. Then you have a converse of this theorem also. Similarly, corresponding angle theorem, which says that if you have two parallel lines, then the corresponding angles are equal. And then you have a converse of this theorem also. Similarly, alternate angle theorem, which says that you have two parallel lines, then the alternate angles are equal. Then you also have the converse of this theorem. Then this says that if you have two parallel lines, then interior angles on the same side, they add up to 180 degree. Fine. And then you also have converse of this theorem. So total of 8 theorems you have to remember now. Is this okay?
Yes, ma'am.
Okay. Please try to remember it like this. You should use your pen and paper and try to summarize whatever you have studied so far. So you will never forget which theorems you studied. Otherwise, it will all messed up in your mind. Let's move forward. Now, there's a new thing. We are done with all these theorems. Just one more thing we have to do now is, which says that lines which are parallel to the same line are parallel to each other. So let's have three lines here, three parallel lines first of all. This is any one line, two line, and three line. Let me give it some names. This is my line L, M, and N. Okay. Now this is a transversal passing through all the lines. Let these angles are 1, 2, and 3. Now what is given to me here is, it is given to me that line M is parallel to line L and line N is also parallel to line L. Okay. This is parallel to L and this is also parallel to L. So we have to prove that these two are parallel. All right.
Hmm. Okay.
We know they both are parallel to line L, but we have to prove that they are parallel to each other also. This is the theorem, that lines which are parallel to the same line are parallel to each other. So which is the same line here? Line L. Okay. So we have to prove that M is also parallel to N. So let's do the proof. Basically, I draw a transversal. I just draw it before itself. So first you draw a transversal and then you name these angles 1, 2, 3 to prove it. Now it is given to you that M is parallel to L, okay, which is given. Now see, if line M is parallel to line N, then by using the corresponding angle theorem, angle 1 is equal to angle 2, right? Corresponding angles, fine. Yeah, please say yes or no or something.
Yes, ma'am.
Okay. Now again, N is given parallel to L. So this time angle 1 is equal to angle 3, right?
Yes, ma'am.
Because now these two lines are parallel. We are talking about these two lines. So if line N is parallel to line L, that means angle 1 is equal to angle 3. Same corresponding angles. Okay.
Yes,
Now
ma'am.
look at this equation 1 and equation 2. So both have angle 1 on the LHS. So from equation 1 and 2, angle 2 is equal to angle 3, right?
Yes, ma'am.
So now you know angle 2 is equal to angle 3. They are corresponding angles. So now you know that the corresponding angles are equal. So what does it imply? Please speak up. We just did a revision. This is the converse of corresponding angle equal. Now it is given, you have proved that the corresponding angles are equal. Therefore, the lines are parallel, isn't it?
Yes, ma'am.
Why don't you people speak up? So we have proved that angle 2 is equal to angle 3. So simply write by converse of corresponding angle theorem. Sometimes I write in short, you can write it completely. Corresponding angle theorem. So line M is parallel to line N. Proved. Please don't use all these rough. This is my rough work. All right.
Okay, ma'am.
Just write M and N. Give the names to the lines M and N. Okay, written?
Yes, ma'am.
Okay. Actually, I want to do the examples also because examples are also important in this chapter. They are usually asked in the examination. And then I think in the next class, we will come to the exercise. Okay, let's do this example. It's very interesting. Read it carefully. So always write whatever is given to you. This makes your things simple, and always write what you have to prove or you have to find. Sometimes you have to find, sometimes you have to prove. So what is given? If PQ is parallel to RS, okay, this is the actual diagram. So it is given that the line PQ is parallel to line RS. It is very important statement which is given to you. It is given that angle MXQ is equal to 135 that you can see in the figure. Angle MYR is equal to 40 degree that also you can see in the figure. Now you have to find angle XMY. That means this angle you have to find. All right. Or this angle I can say.
Yes,
This,
ma'am.
yeah, this you have to find out. Okay. What we will do is, see, this is the actual figure which is given to you in the question. So what we will do is we will draw a line, or you can say draw AB parallel to PQ. Okay, we have drawn a line AB which is parallel to line PQ. Okay, this much we have done. Now solution. Done, this much written.
Yes, ma'am.
Okay. Now okay. Now first let me call this my angle 1 and let me call this my angle 2. This is I'm just using it angle 3 and I'm just using it angle 4 because I don't want to write their full names again and again. You can also write it like this. Now look here carefully. It is, see, we have drawn AB parallel to PQ, right? And it is given to us that PQ is parallel to RS, which is given. All right.
Yes, ma'am.
Now we have just now proved a theorem that if the lines are parallel to the same line, that means they are parallel to each other, right? So here AB is also parallel to PQ and RS is also parallel to PQ. This implies that AB is parallel to RS, isn't it? By that theorem. Yes?
Yes, ma'am.
Okay. Now use this. I'm doing it here. Now you can see angle 3 plus angle 1 is equal to 180 degree. Which theorem I have used here? We have just now did it. Interior angles on the same side of transversal are supplementary, right?
Yes, ma'am.
We have done it. So if line AB is parallel to line PQ, that angle 1 plus angle 3 is equal to 180 degree. Now angle 3 is already given, which is 135 plus angle 1, which is 180 degree. So from here you get angle 1 is equal to 180 degree minus 135 degree. So angle 1 come out to be how much? 45 degree. So one thing you have found out, angle 1. Now see here. Line AB is parallel to line RS. Okay, I think there is some next class starting. So line AB is parallel to RS now. We have just proved. See here, we have proved it, right? Now, if these two lines are parallel, that means angle 2 is equal to angle 4, vertically opposite angles, sorry, alternate angles, right?
Yes, ma'am.
So angle 2 is also equal to 40 degree. Now you are supposed to find the complete angle XMY. So angle XMY is equal to angle 1 plus angle 2. So just add the two angles. So angle 1 is 45 degree plus angle 2 is 40 degrees. So this come out to be 85 degrees.
Yes, ma'am.
Yeah, so you have found the answer. Okay. I think we have 3 minutes. We can do one more example. Have you written?
No, ma'am.
Okay. Please also mention whatever I have written in the figure. Otherwise, you will get confused which is angle 3, which is angle 4.
Yes, ma'am.
Yeah, please write it similarly. Okay, let's quickly do the next example. I'm moving forward now. Fine?
Yes, ma'am.
Okay. This is also, you can take a picture or something. I mean, it's this because this is example, it is already solved in your book also. Just try to understand what I'm doing. That is main important. That is the important thing here. Let's move to the next example. Oh, okay, I have not pasted the figure. Let me draw the figure by hand. Now, this example say that if a transversal intersects two line, okay, this is the figure. Let me draw it first of all for you. This is a, you must be having your book. You can see there also. There's a transversal P, Q, R, S. Anyway, I'm drawing it here. Just look here carefully. A, D, I'm saying it loud. This is my point B, this is my point C, okay? Now, this is the complete angle and this ray is the bisector of this angle. That means this angle is equal to this angle. Bisector means it divides it into two equal parts. Now, again, this line is the bisector of this angle. So that means this angle is equal to this angle. Let this ray be G. Okay. So I'm doing one thing. Let me give this angle some name. This is my angle 1, only this much, and this is my angle 2. So what is given to you in this figure? If a transversal intersect two lines such that the bisector of a pair of corresponding angles are parallel, it is given to you that BE is parallel to CD. Look in the figure carefully, that BE is parallel to CG. That is given to you. I think some participants have joined the, we should end up the class now. We will do it in the next class, and then I'll try to inform you. I'll try to contact you on message if we can arrange an extra class, right?
Okay, ma'am. Thank you.
Okay, and Miraj, please try to find out some time. I need a class.
Hmm.
Okay,
Okay, sure.
sure. Okay.